In this final video, we're going to look at how you can combine gas chromatography with mass spectrometry to improve the usefulness and make it more powerful as a technique. So we know that gas chromatography is great to separate the components of our mixture, but it's not very good at identifying them. We've got all those limitations to identification. It's not very good. So what we do is we tag to the back of our gas chromatography machine a mass spectrometer. So we sort of attach, as the samples come out, they pass from the gas chromatography column straight into a mass spectrometer, and the mass spectrometer is going to analyse those components. And that's going to give us much more information. Okay, so we have a look. We've got our sample, and we're going to inject it into our gas chromatograph. It's going to come out, and what we can see here, we've got our chromatograph here. This is our chromatograph. Yeah, and we've got lots and lots of peaks. So lots of components of our mixture. And as they come out, they're going straight into the mass spectrometer. And the mass spectrometer is going to produce a mass spectrum of each of those components. So for every peak on that chromatograph from the GC, we're going to get another spectra like this. So we're going to get quite a lot of mass spectra from this technique. What sort of things do we remember about mass spectrometry? Well, we remember that the peak furthest to the right with the highest M/Z value, so that's the highest mass to charge ratio, is called the molecular ion peak. And it's going to give us the MR. Now we would need to know which type of technique has been used. Now an exam board should really tell you which type of ionisation has been used to help you work out MR, but you can tell from this spectra. How could you tell from this spectra which type of ionisation has been used? So this spectra has got lots and lots of additional peaks, fragment ions. Now if you've got lots of fragment ions, you must have used electron impact, because remember that electrospray doesn't produce fragments. So the molecular ion peak is just going to give us the MR, because the value for that on the bottom scale here is the MR. There is a small peak just to the side. Remember that the small peak just after is the isotopic peak due to carbon 13 and hydrogen 2. So just remember that that happens too. Let's just remind ourselves a bit about mass spectrometry. So the peak with the highest mass to charge ratio is the molecular ion. So it's going to give us the MR. And fragments are going to provide detail of the structure. So what we've got here is two isotopes. These are both C4H8O, isomers, sorry, not isotopes. And these are both C4H8O. So they both have the same MR. We can find that MR, that molecular ion peak, at 72. And we can spot that we've got an isotopic peak as well. And we can see that that is occurring at 72. Oops. The molecular ion peak is at 72 in both of these spectra. What we've also got here is we can see a very big peak at an M/Z value of 43. And if you imagine breaking this molecule in half, fragmenting it, and you add up CH3CO, remember that they're always positive ions in this mass spectrometry technique, you can see that adds up to 43. So we've got a fragment at 43. So the fragments can tell us things about the structure. So what are the uses of GCMS? Where would you find GCMS? Well, it's used in forensics, because you only need a tiny amount, and drug analysis, so maybe you're analysing sports people for banned steroids, maybe you're looking to see what, if you find a small amount of white powder, whether it's a banned substance. We've got environmental analysis, so you're collecting river water samples or soil samples, and you're trying to find out what's there. Maybe you might find it in airport security, so you go through airport security, and one of the tests that they can do is sort of blow air on you and collect the vapours that come off you to see whether you might be carrying drugs. They're put onto space probes so that they can analyse the environment, the air, the soil on extraterrestrial planets. We're out in space, so we can find out what elements are present at different places in space. So that is the end of our video on GCMS.